Okay friends, in this session I start one of the question is that if you have two signals here, one of the signal is sine x and another signal, for example sine x plus 90 degree, that both of them lags each other, then if we combine both of these two signals, signal sine x plus sine of x plus 90t. Now the question is that what would be the y is equal to sine x plus 90, what it would have the maximum value, what the maximum value of y will be. Would it be 2 and minimum value minus 2, or it would be lower than 2 and higher than minus 2, or maybe it would be higher? This is the main question. If both of these two signals does not have any phase shift, if it does not have any phase shift, this is, for example, we take it as an example as both of them as a sine x and a sine x. The answer of this one is clear. What would be the maximum value? It would be the maximum value, it would have 2, and the minimum value it will have minus 2. That is clear, that we would see. This is the result. It would have the maximum value of 2 and the minimum value of minus 2 it will have if both the signals are having no phase shift. It means the maximum value of each one becomes plus the maximum value of another one. That become here the maximum value of each one is 1, and the combination would have a maximum value of twice of it. Now the main question remains still as it is, that if there are some phase shifts between the first signal and another second signal, what would be the combination of the two? Whether it would be higher or lower than 2 for the maximum value, and for the minimum value would it be lower than minus 2, or it would be higher than minus. Now on the simulation, it is programmed. Now we have drawn the figure of the combination of the two signals while both of them are not in phase. They have some phase shifts, but the maximum value each one they have 1. Now we had drawn the combination of the both. It means we have the combination of sine of x plus sine of x of plus 90, that is phase shifted by 90 degree. Another one, we can see that this phase shift causes that the maximum value reduces from the 2 and the minimum value gets a little higher from this phase shift. If phase shift is, for example, 90 degree, then we can decide that this how much this one will be, and it would be solved from trigonometric equation, that what would be the maximum. Now to find it, we need to find the point of intersection of the both. It means this point, we should find this point, this angle that it has. At the point of intersection we find that angle. Here in our case this angle is 45 degree, because why it is 45 degree? Because sine of x plus 90 is cosine of x at the point that sine of x is equal to cosine of x, that point of intersection. That sine of now the point that sine of x is equal to cosine of x, we from the trigonometric equation we can find that x is equal to 45 degree. Now we replace this 45 degree on our equation, and we can find the minimum value and the maximum value. It is 45 of the sine of x and 45 of the sine of 45 degree and the sine of 135. Here becomes 145 plus 90, 135 plus sine of 45. That is, sine of the 45 degree is root 2 by 2, and the sine of 135 is also root 2 by 2, so it becomes 2 root 2 by 2. At the result, 2 by 2 cancel, it becomes root 2. Root 2 is nearly 1.4 something. Here becomes 1.4. the maximum value, and minimum value is minus 1.4. Accordingly, we can find for another x. Now the question is, what is the usage of this discussion? Is if we have two transmission lines, the one is coming from L1 comes from another grade, from grade A, for example, and transmission line 2 comes from grade B. Both of them having different L and C. It means inductance and capacitance. It would be dash, C dash, and double dash, inductance double dash, and capacitance C double dash. It has both of them. Now, as the inductance and capacitance of both the transmission lines differs, they will have the signals which pass through these transmission lines. They will be in different angles, and maybe they will have some lagging. Now here, if we combine these two signals of coming from different areas with having lagging, for example, this one be lagging by, as we discussed before, if it be lagging by, for example, 30 degree, then accordingly it will have the combination of the both will not be the twice of the each one. For example, if we have the first one, I mean that the combination will have lower maximum and minimum value, and accordingly the RMS value of the signals will be different. For example, if we consider the of line 1 as a V1 and line 2 as a V2, and V1 be, for example, 230 degree, 239 degree, for example, maximum value, and V2 also having 39 volt, 239 volt and 239 volt. If they be lagging, the combination of the both, how much it be as expected, for example, it be in series. So we are considering voltage. We can consider here current, because the voltage will be, there are some another discussion about the voltage, that first one. Now we consider as I1 as a for example 10 ampere. First one, I1 as a 10 amperes, and I2 we take it, we suppose that I2 also having 10 amperes current. Then if these two currents, which are two signals, they lag according to the inductance and capacitance of the transmission line, then the combination of these two currents will never be 20 ampere, and it would be lower than this 20 ampere. The usage is the design of these comparators, the design of maybe reactive power controls, or maybe the design of equipments like filters, design of the filters. It will be accordingly decided that which amount of the current we want to filter, the maximum current of the board, and which amount of the current we would need. For example, if it is lower, we design our filters that we need the current of maximum 20 ampere, and the remaining will be filtered. It will at the end, at the output, we'll never have any current, because we already filtered the current below 20, and the current, that actual current that we have, the combination of this both current are lower than 20. The design of the filter that already filters this current with this amount of the maximum value and which amount of the frequency. Now at the output we will not have any current. This is the most important case. Also in the design of the registers, while the registers are nowadays they are in digital, but that digital also it differs if the combination of the both of the signals having different angles, and they will have, if they have different phase shifts, then the combination will have a problem.